आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सॉल्यूशन पाओ। डाउनलोड नाउ।
Hello everyone. In this problem we are given two statements. Statement 1 says that the line represented by this equation lies in the plane 2x minus 3y minus 4z minus 10 equal to 0. And statement 2 says that if the line represented by r vector equals a plus lambda b vector lies in the plane r vector dot c vector equal to n, where n is a scalar, then b vector dot c vector equal to 0. So we have to tell that which of the statement is correct and whether statement 2 is a correct explanation for statement 1 or not. So in this problem, first of all, let us see that we are given a line r vector is equal to a vector plus lambda b vector in statement 2. So if we consider this as a line, this means that this line is passing through a fixed point a vector. This is a fixed point on the line, and this b vector is the direction vector of r vector. B vector is the direction vector, and since this r vector lies in the plane r vector dot c vector equal to n, this r vector is lying in this plane, and this form of plane represents that this is the normal vector. In this type of plane representation form, this vector represents the normal vector of the plane, and since this line is lying in this plane, therefore the normal vector of the plane will be perpendicular to this line. This normal vector, let this normal vector be represented by p. So this p vector will be perpendicular to this r vector, and the r vector is containing the direction vector, so p vector will also be perpendicular to direction vector, that is b vector. Therefore in this case p vector is c vector, so c vector dot b vector must be equal to 0 because perpendicular vectors dot product is 0. Therefore c vector dot b vector equal to 0, or we can say b vector dot c vector is equal to 0, and this is what we are given, b dot c is equal to 0. So statement 2 is correct. Now we use statement 2 to find statement 1, whether this line lies in this plane or not. So we will check b dot c in the statement 1, and if it will come 0, then this line will lie in this plane. So the line in statement 1 is given as x minus 1 by 1 equal to y minus 0 by 2 equal to z plus 2 by minus 1. So in this type of line representation, in this type of vector representation of a line, the denominators represent the direction vector, coordinates of direction vector, and the numerators represent the fixed point. Therefore the direction vector comes to be, let d vector, that comes to be I cap plus 2j cap minus k cap. Hence the direction vector of the line comes to be this, and plane is given 2x minus 3y minus 4z equal to 10. Now this is the representation of plane, and in this representation the normal vector can be given as 2i cap minus 3j cap minus 4k cap. The coefficient of x, y and z respectively gives us the normal vector. So we are having the direction vector and the normal vector, and let us take the dot product of direction vector and normal vector. So we will receive dot, after doing the dot product, it will be 2 minus 6 plus 4. So if we solve this, here we are getting 0, hence verified, as we have proved in statement 1 that for a line to be lying on in some other plane, it should make the condition normal vector dot the direction vector should be 0, and this we have found out here that the direction vector and the normal vector dot is equal to 0. Therefore this particular line is lying in this particular plane. So statement 1 is also correct, and statement 2 is also correct, and statement 2 is a correct explanation for statement 1. Hence option A will be the correct answer.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।